Hi, I welcome you all for this part 2 video of Unit 1 in Power System Operations and Control. This is Dr. R. Lavanya, Triple Department from Sri Muthukumaran Institute of Technology. And today's lecture, we are going to discuss about the requirement of good power system, necessities of voltage and frequency regulation, and the references used for this lecture. The requirements of a good power system. The four important requirements are reliability, quality, cost, system stability, and safety. The first one is reliability, that is continuity of service. The most basic requirement is that power must be available 24/7 for all the 365 days. Redundancy, if one transformer blows or the tree falls on a line, the system should have a plan B. That is an alternate route for continuous power supply to keep the lights on. The spinning reserves are the basic supplies during these conditions. The maintaining the synchronized but unloaded generation capacity to immediately compensate for sudden power losses. The second important requirement is power quality. A good power system must provide electricity within a narrow statutory limit to ensure the health of connected loads. Frequency stability. In India, the operation frequency must be maintained within 49.9 to 50.05 Hz. Voltage regulation at the consumer end should be maintained in a nominal value. Harmonic distortions, it should be usually limited to 5% of the voltage. The total harmonic distortions should be minimum. The next important requirement is the operation efficiency, that is minimizing the cost of energy served. Economic load dispatch is to be followed. The distribution of the total load among the various generation units such that the total cost of generation is minimized. Optimizing the power flow to reduce the losses in the transmission and distribution network. The system stability is the fourth important requirement. That is the ability of the system to return to the steady state after the disturbance. The main disturbance occurs due to the transient. The transient stability is very important, and it is the ability to maintain the synchronism when subjected to severe disturbances. Example, a three-phase fault. The dynamic stability of the system, the ability to damp out the low frequency oscillation, that is 0.1 to 2 Hz, inherent in the interconnected system, is very important. The fifth requirement is the safety. The system must isolate the faulty work and leave the LT system to execute their operation perfectly. The fault clearance should be done immediately to prevent the failure in the generator operations. The next topic is the necessity of voltage and frequency regulation. Before entering into this topic, we have to know the basic requirement of the voltage and frequency regulations. Frequency is directly related to the real power, and if generation is not equal to load, the frequency changes. The basic principle in power system is power generation is equal to load. If the load increases, the generator slows down and the frequency decreases. And if the load decreases, generation speeds up and the frequency increases. So the control of the frequency is obtained by the real power control. And similarly, we can control the reactive power using the voltage. In general, real power controls the frequency and the reactive power controls the voltage. So now if we focus on frequency generation, that is the real power control. The balancing of the two power, that is the generated and the load, is very important. Frequency is an index of the balance between the total power generation and the total load. If the demand exceeds generation, frequency drops, and if generation exceeds the demand, frequency rises. So this makes us to care a lot about the equipments we use. Most AC motors and the turbines are designed for a precise speed. Example 50 Hz. Deviations can cause overheating, vibrations, and mechanical failures in the turbine blades, which makes us to spend a lot amount in correcting the errors. The next topic is voltage regulation, which is basically a reactive power control. The consumer perform, that is the low voltage can cause the motors to stall or overheat, while high voltage can cause insulation failures and burn out the applications. Therefore, the system stability is to be focused. Power voltage levels are maintained by managing the reactive power. If the voltage is not regulated, it can lead to the voltage collapse, resulting in widespread of blackouts. These are the reference used for this small lecture. Thank you.